Hi, my name is Erick, and this is my oral presentation for my Capstone research project focusing on airport infrastructure and capacity constraints in the United States. Before discussing the individual program outcomes, I'd like to provide background on the topic. So the problem is U.S. airport infrastructure and capacity constraints. There are several recommended solutions, and of course there's challenges with implementing those solutions. The aviation industry exists and thrives because of the global infrastructure containing manufacturers, investors, regulatory agencies, airlines, and airports, to name a few. The goal of this project is to review the problems surrounding the infrastructure of U.S. airports and its relationship to capacity constraints. The current infrastructure at many of the busiest airports in the U.S. is antiquated, having been built from converted military air bases. Air travel demand has since outgrown the current capacity at many of the U.S. airports. This is causing capacity constraints, which leads to flight delays, and is therefore driving up the cost associated with commercial aviation. Several opportunities exist to increase the overall health of the U.S. airport infrastructure and improve overall operational capacity. Some of the solutions include conducting improved forecast by utilizing better metrics. In the key area of funding, research has shown that there is ample opportunity to increase airport revenue for capital development projects by lifting the current federal cap on passenger facility charges. This can help airports fund runway and taxiway enhancements. And lastly, applying better airport demand and capacity management strategies can help airport officials regulate the flow and capacity of both airside and landside operations. Some of the key challenges with implementing these solutions include the funding requirements, external factors such as the current economic and political environment, the time necessary to implement the solutions, and lastly, the overall scale of the projects. Okay, so in discussing the first program outcome of aviation, aerospace, and aeronautical science, this research project covered those topics in multiple areas. Some of the bullet points provided here show that. I discussed the origin of airports and the history behind commercial aviation growth, the deregulation of airlines, the hub and spoke model of airports, runway design and layout, and delay propagation impacts that stem from the bottleneck airports and the U.S. air transport system. So discussing airports, it's important to note that the dramatic growth was really experienced in the mid to late 1930s. This growth spurred the development of organizations and policy changes aimed at directly funding the development of the American aviation infrastructure. During this period, in 1938, the Civil Aeronautics Act was enacted into legislation, and that really established the bedrock of regulatory commercial aviation guidelines for the United States. Fast forwarding into the late 70s, the advent of jet airliners and the Airline Deregulation Act of 1978, the increased demand had been challenging the capacity of commercial airports across America ever since. The deregulation really promoted increased competition between airlines, which really led to lower ticket prices, which also led to cities competing for that market share by serving as primary airports. And the airlines adopted method of hub and spoke route structure. So airports were really competing to serve as those airport hubs for airlines. Discussing a little more about runway design and layout, that's a critical factor to operational capacity. And given that the annual traffic is expected to double or possibly triple by 2025, airport capacity for airside operations will be the utmost importance for airport officials. The eventual integration of the FAA's next-gen air transportation system will enable aircraft to take advantage of new guidance system technologies that will increase capacity, but currently it's not implemented across the entire network of U.S. airports. With the eventual integration of the FAA's next-gen system, airports should look into developing new runways that provide airports opportunity to reduce congestion and increase operational capacity. With regard to delay propagation impacts and bottleneck airports, it's important to note that the majority of the U.S. airports operate with adequate capacity and experience little to no delays. However, the airports that do suffer from capacity constraints often experience delays that propagate throughout the entire air transportation system. These airports are often referred to as bottleneck airports as they cause the most delay propagation in the national airport system. The current state of airport infrastructure is related to aviation safety because of the increased congestion experienced at many airports. Reduced operational capacity for airside operations often means that airports are congested, and therefore this increases the likelihood of a safety incident. High levels of congestion have actually resulted in the FAA instituting a high-density rule at some of the busiest airports in the U.S. The high-density rule is still in effect at only 2 airports, JFK International and LaGuardia in New York. The goal of the high-density rule is twofold: to reduce congestion and promote safe operations. Another safety consideration when discussing capacity constraints is the environmental impact. As mentioned earlier, congestion leads to flight delays. But what's truly interesting is the environmental impacts associated with these delays. For example, in 2007, it was reported that flight delays resulted in an additional 740 million gallons of fuel being consumed. That led to the release of an additional 7.1 million metric tons of carbon dioxide. And of course, the effective design and layout of runways and taxiways can lead to both improved capacity and operational safety. Coupled with the FAA's next-gen system, airports can begin to enhance runways and taxiways that satisfy both safety standards and meet capacity requirements. Okay, and discussing the next program outcome of aviation legislation and law, you can see here the specific bullet points that touched on this topic, including the regulatory organizations such as the FAA, ICAO, and IATA. Also discuss specific historical legislation such as the Civil Aeronautics Act of 1938, Airline Deregulation Act of 1978, the Aviation Safety and Capacity Expansion Act of 1990, the National Plan of Integrated Airport Systems, Airport Capital Improvement Plan, and of course, Airport Improvement Program for federal funding. As I mentioned earlier, the Civil Aeronautics Act of 1938 was enacted into legislation and really established the bedrock of commercial aviation guidelines for the U.S. This piece of legislation ensured that the U.S. aviation infrastructure would receive the necessary attention required for a nationwide overhaul of existing airports and facilities. This effort established the basis for increasing the government's involvement with funding airport improvement projects and ultimately led to the federal regulatory oversight via the creation of the Federal Aviation Administration. The Airline Deregulation Act of 1978 served as a key contributor that led to the current state of capacity constraints across U.S. airports, mainly because the increased competition between airlines has allowed for cheaper ticket prices, which has promoted the growth of air travel. Passenger facility charges were established by the Aviation Safety and Capacity Expansion Act of 1990. This legislation allows for airports to impose a charge on passengers in order to help increase funds geared towards airport safety and capacity-related projects. The National Plan of Integrated Airport Systems and the Airport Capital Improvement Plan were established nearly 20 years ago in 2000. The goal of this was to identify the airports in the U.S. National Air Transport System, assess their role in the overall system, and determine the amount of Airport Improvement Program, or AIP, funding they'd be eligible to receive. The Airport Improvement Program offers an equal opportunity for airports to apply for federal grants that assist with funding, planning, and developing projects listed within the FAA's national plan. For airports to operate safely and efficiently, there is a great deal of input required from airport officials and operation managers. Airport capacity is often determined through conducting forecasts, and managing the capacity can be achieved by scheduling intervention. In addition to historical forecasting methodologies, airports should also conduct a supply-demand equilibrium analysis to better determine capacity-related issues. Such analysis can lead to findings that have significant impacts regarding an airport's congestion and funding. Supply-demand equilibrium analysis also helps in determining the appropriate capacity levels at an airport. These type of analyses offer a unique opportunity to model the equilibrium capacity of an airport and examine the effects of increasing or decreasing operational capacity. Equilibrium analysis provides a more accurate estimate of the benefits gained through capital investment. This is important because limited funding opportunities require that capacity improvement projects yield a positive return on investment, typically in the form of reduced flight delays and reduced congestion. Given that most of the flight delays are caused by disparities between demand and capacity, effectively applying airport demand and capacity management offers a low-cost administrative solution to improve capacity utilization. Scheduling intervention aims to reduce the number of flights during the most congested hours by scheduling a more even distribution of flights throughout the day. This integrated approach of effective airport demand management has the potential to resolve a great deal of congestion delays across the U.S. air transportation system. While this may only be a short-term solution, it would offer airports additional time to complete a long-term capacity improvement project, such as runway or taxiway enhancements. All right, lastly, moving on to my SWOT analysis, you can see the strengths here include reduced airport congestion and increased on-time reliability, reduced operational costs, safer and more efficient airport operations, and of course the end result would be an enhanced airport infrastructure. The weakness with this is the time-consuming process of implementing the solutions, lack of airline and airport participation during forecasting studies. Some of the opportunities include a more efficient national air transport system, increased well-being for travelers and airlines and airports, and then their associated economic benefits. And threats include lack of support from the government for funding, and pushback from airlines and consumers, specifically with raising passenger facility charges. On my analysis here, I've come to the conclusion that there's not one specific solution that will both enhance the infrastructure of U.S. airports and relieve congestion. It'll take combined efforts from several different organizations, including airlines, airports, the government, and consumers. Conducting better and more accurate forecasts will better equip airport officials to understand capacity-related issues and allow for a better appropriation of funds for enhancement or development projects. Raising PFCs will allow for airports to narrow the funding gap that currently exists within the industry. And here's a list of the references that I utilized during this presentation. Thank you for watching.